17, 15, okay, so let's see, can check this one. Blue cat. I don't know if I can set this time, but 0010, 0110. The date is 15. I could set it. And this will be a 1616. I say this is 17. 17. This one. Oh my god. Let's see. I have to use this one. 17. This should be okay. Then I can go to compass. This number should be 17. The time is 0 a.m. Okay, then I can put it here. This is fine. Then we can do PDF. I can download PDF. Then I can probably so this why I don't know why this laptop consumes so much power. This is crazy. Control Alt Delete. Is this a memory problem? I think a lot of memory was used by Microsoft Edge. CPU. What's it? CPU. OBS is using CPU. How much network is used? Skype is using some close line and close scarf. Anyway, okay, Thomson effect, we have done this. Helicon waves, I may kind of skipping this. Then I can go to surface plasmon. What is the surface plasmon? An electromagnetic wave that can propagate along the surface of a metal complicates the observation of ordinary bulk plasmons. Let the metal be contained in the half space G, which is larger than 0, G smaller than 0 being vacuum. Assume that electric charge density rho appearing in Maxwell's equation vanishes both inside and outside the metal. This does not preclude a surface charge density concentrated in the plane Z equals 0. The surface plasmon is a solution to Maxwell equations of the form complicated. Q, K, K prime real, K, K prime positive. Part A. Assuming the usual boundary condition E parallel, continuous, E perpendicular, continuous, and this is different. Dielectric constant times E perpendicular continuous, and using the root result 1.35 and 1.29, find three equations relating Q, K, and K prime as functions of omega. Assuming that omega tau larger than 1, plot Q square C square as a function of omega square. In the limit as QC much larger than omega, show that there is a solution at frequency omega equal omega p divided by square root 2. Show from an examination of K and K prime that the wave is confined to the surface. Describe its polarization. This wave is known as a surface plasmon. I think we need a much more explanation, and this I would say is a different topic. This maybe, I don't know if there is more elaborate explanation in some textbooks of electromagnetism or electrodynamics. But I think these topics, like problem number 4 and problem number 5, should be separated, should be learned, should be studied separately in more depth. in more depth, in detail. I think this is not like a short chapter and programs. I think this contains a lot of electromagnetism, I would say. Because the configuration they are talking about is not clear. Like which way the wave is propagating and what the direction of electric field, what's the direction of magnetic field. The things like that are not so clearly stated and don't understand what exactly the phenomena are going on in these programs. So I would say this is pretty hard to do. So I would rather skip this program. But I remember that this type of program, number 4 and number 5, then if I find good textbook dealing with these topics in more depth, then I will try to introduce those whenever I found such materials. Then I can maybe stop today. The next time we can move on to chapter 2, Sommerfeld theory of